Good day, grade 12 learners and teachers. Welcome to today's mathematics lesson. My name is Mr. Shongwe, and this lesson is brought to you by the Gauteng Department of Education in collaboration with the Hyperbola Discovery Center. All right, good people, this is the D-Day for paper 1, okay? So we want to make sure that we assist you in finalizing your preparations for paper 1. Obviously, we cannot be able to do everything. We'll be touching on only aspects of functions and inverses, as well as aspects of differential calculus. All right. Now, we can then begin. Okay. Now, by the end of this lesson, it's imperative that you are able to set targets per topic, unpack the checklist on functions and inverses, okay? Revise functions and inverses by focusing on exam type questions, unpack the checklist on differential calculus, and revise differential calculus by focusing on exam type questions. Remember, we are available on our WhatsApp interactive number. Think it would be at the bottom of your screen. So keep on checking it and keep on interacting with us. You can ask us questions on the lesson that is currently ongoing, okay? Right, remember also with the checklist is available in all topics, okay? And it was shared with all the schools, so I believe that you have the checklist in your position where you can go to any chapter or every chapter, I should say, that would be in paper 1, and then you'll be able to see all the examinable concepts and check whether you have covered those concepts, and then you can tick on the checklist. All right. Now, let us look at paper 1, mark distribution and target setting. You can see algebra and sequences, they both weigh 25 with a variance of 3, which means they range between 22 to 28 marks. And then you can see differential calculus as well as functions. They are the most highly weighted topics in paper 1, okay? So they are highly weighted, these ones, because if you check, if you combine the two, they would be at 70, all right, with a variance of 6 there. So it means that functions, they carry 35 with a variance of 3, and calculus carries 35 also with a variance of 3. With those two topics, you should be able to get more than 40% of the paper, or rather more than 30% of the paper, but it forms more than 40% of the paper. So if you are good with those topics, then you'll be good to pass the paper, okay? And then we have finance, and then we have probability, both weighing 15 with a variance of 3. Can also see the range in terms of the marks, and you can see the sequencing in the question paper. Normally, in question 1 is algebra. Question 2 and 3 is sequence and patterns, and then question 4, 5, and 6, usually it's functions, where question 4, at times it's just sketching. Question 5 is interpretation of sketched grade 11 functions, and then question 6, that's where you normally find your inverse functions. Question 7, that's where you normally find your finance, okay? And then question 8, 9, and 10, that's where you normally find your differential calculus. With question 8 being the basic calculus, question 9 being your cubic functions, and question 10 being your optimization, and then you normally find your probability in question 11. Remember, good people, your exam tomorrow will have a special answer sheet, all right? A special answer book, okay? So the special answer book is aligned with the question paper, all right? Please make sure that you use a pen only in that special answer book, all right? Even when you draw graphs, okay? Even when you draw graphs, even in paper 2, when you do your constructions, please do that in pen, okay? use pen only, all right, because your scripts must be scanned and they'll be marked online. All right, so let's get on. You can see the minimum targeted marks here. You can see that for algebra, you can target a minimum of 15 marks. And then for patterns and sequences, a minimum of 12 functions, 15, 5, 10, and 10. If you are to reach those particular targets, then you'll be able to get 67 marks and you only need 45 marks to pass. Remember, this is the minimum target for what? For just a pass, all right? If you are aiming at getting more than 30%, more than 40, more than 50, then your targets should be set a bit higher, okay? So, but here for this presentation, I only looked at target setting for a minimum pass, all right? Now, this is the information sheet as you'll find it tomorrow, all right? As you'll find it in the question paper, all right? If you can check here, you have your formulas here that speak to sequences, okay? Sequences and series, okay? And then you can see here you have the formulas here that speak to finance, growth and decay, all right? It accommodates also growth and decay. But here you can see these two that you are now looking at the annuities, all right? You are looking at the annuities, and then obviously this one is for the first principles, all right? Now you can check the next page. You can see most of the equations here are for paper 2, but these ones can also be used in paper 1. You can use these ones in what? In functions, okay? Please be able to integrate. Sometimes they can give you a straight line or a linear function, okay? They can give you a linear function, maybe sketched on the same set of axes with a parabola. And then from there, they give you the angle of inclination here, all right? They say it is 45 degrees, all right? So this angle of inclination that indirectly gives you what? The gradient, because you have to use the gradient is what? Is the tangent of theta. So you should be able to integrate and not say this is only applicable in paper 2. It can also be applied in paper 1. So there would be questions where they integrate between sections of paper 1 and sections of paper 2. You'll surely get one of such questions tomorrow. So you should be ready to be able to tap into your knowledge of paper 2 to also work with paper 1. All right. And then now, these ones are paper 2, predominantly paper 2, what you call formulas, okay? It is trigonometry, okay? It is trigonometry. We are not saying you won't get anything in paper 1 that has to do with this. You might be asked to calculate the area where you can use the area rule, all right? You might be asked something that may also push you to be using the cosine rule or the sine rule. So you need to be able to integrate, all right? And then now let's look at functions, the concepts that you'll be tested on tomorrow. And then these are the concepts that you should know to be able to get marks on functions, all right? You should be able to sketch linear, parabolic, exponential, and hyperbolic functions. You should be able to sketch each of these functions, all right? Sketch them first, all right? If you are convinced that you've done that and you have that covered, you can give a tick. I've seen learners making a lot of mistakes here on exponential functions, the sketching of exponential functions. Please make sure that before you sleep tonight, you've practiced how to sketch an exponential function. In this form, not the one that you do in grade 12, the inverse one. In this form, a times b to the x plus p plus q, all right? Go back to your grade 11 and try to check whether you can be able to sketch these exponential functions. Very, very important. Now, determining the equation of all functions in this particular form that is given there. Remember, the straight line is y is equals to mx plus c. The parabola is y is equals to ab, or ax squared plus bx plus c. Or in the turning point form, remember this is in the dual intercept form, okay? And this is in the turning point form. You should be able to complete the square, and you should also be able to move between these two, all right? And then there's the third one, okay? Y is equals to a into x minus x1 in x minus x2 that we normally use when we determine the equation of a parabola given the x-intercept. All right, then we have the rectangular parabola, or the rectangular hyperbola, I should say, and then we have the exponential function as well there. All right, these are functions where you should know how to determine their equations. All right, and then from there, write down the domain and range of all the functions. If you've covered that and you know your domain and range, it will be asked tomorrow. You cannot run away from it. You'll be asked about domain, you'll be asked about the range. Okay, so you should be able to do domain and range for each and every function there. Then you should be able to deal with a situation where you should interpret grade 11 sketched functions, all right? Functions is sketched. There are questions that are derived from the function sketched, should be able to answer them, all right? And then you should be able to determine the inverse, all right? Sketching the inverse function of a straight line and writing its equation. Remember, the straight line is ax plus q, all right, or mx plus c. You should be able to determine what? To determine its inverse equation and also sketch the inverse. You should also be able to do the same with the parabola in the form ax squared. However, here you should also know how to restrict the domain. Please do look out for that, the restriction of a domain of a quadratic function, so that its inverse becomes a function, all right? And then remember also to test, how to test whether a certain relation is a function or it's not a function, by using the vertical line test or by using the mappings. You should also be able to write down the equation of an inverse of a parabola if the domain was restricted, okay? Very, very important. And then you should also be able to sketch the inverse function of an exponential function. So this exponential function is given in this form. Y is equals to a to the x, okay? Should be able to then determine the inverse of that. If you are able to do that, you give it a tick on your checklist, and then you should be able to sketch the logarithmic function. Sometimes you guys struggle with this. You should be able to sketch the log function, right, if given the equation in that form, and then you should be able to interpret grade 11 and grade 12 functions under the following headings, all right? Subheadings: horizontal, vertical, and diagonal lengths. You should be able to calculate the length, and remember, the length is always positive. You should be able to work with points of intersection. F of x equals g of x. This is an application of simultaneous equation, all right? You should also be able to determine the distance between two functions, top graph minus bottom graph, all right? And then you should also be able to work with inequalities in functions for which values of x is f of x greater than g of x. That's what you need to do. Transformations: you should be able to answer questions of the nature of transformation, where sometimes they say, determine the range of what? If you are given the graph of f, they say determine the graph or the range of what? H of x is equals to f of x plus 2. So you see that they're formulating a new function h by transforming f. What is the transformation? F is moved 2 units up, all right? You should also be able to write down the transformation in weights, okay? And the nature of roots, using the graphical approach, not the discriminant, okay? The graphical approach, for which values of k will f of x equals k have equal roots or have two positive roots, or would have a non-real root. So you should be able to do that using the graphical approach only, right? Sketching of graphs when they given the properties. Sometimes you are given the properties of functions and they ask you to sketch the function. So function notation and features of the graph can be used to do that. All right, now today remember, we are finalizing your preparation. So it's more of the work being done by you, and then from there we correcting the work together, so that there can be learnings that occur as you finalize your preparations. This is not the time where we do things for you. This is the time where you do most of the work and we check and lead you through the correct way in which you should do things, so that you can identify your mistakes and correct them before you write tomorrow. Right. So with that being said, there is the first activity here. It's an activity on a hyperbola. Okay. It's an activity on a hyperbola. I'm going to give you just 10 minutes. Okay. Just 10 minutes for you to work around this activity. Please respond to this as quickly as you can, all right? So that we can mark it together and move forward, okay? Your 10 minutes time starts now. Right, hello and welcome back. I hope you were able to do this basic question. Okay, let's go through it. The first question was calculate the x and y intercept of f. Remember the x-intercept, you put y to be 0, and the y-intercept, you put x to be 0. So if we start, we are starting with x-intercept or the y-intercept because x is equals to 0. So this is the y-intercept. We let our x to be equals to 0. So if we let x to be 0, where we see x, we put 0, and then we get that f of 0 is 3, which means that when x is equals to 0, y is equals to what? Y is equals to 3. So that's what we have as our y-intercept, okay? Now let's check the x-intercept. We put y to be 0. When you put y to be 0 here, you have x plus 3 over x plus 1. And then if you cross multiply that, 0 multiplied by that is 0. So you get 0 is equals to x plus 3. Okay. And then if you transpose the 3, you get that x is equals to negative 3. All right. So which means that your x-intercept would be negative 3 and 0. How do we mark that? We mark putting x to be 0 there, as well as getting the value 2 marks, and then putting y to be 0 here, or rather simplifying this here and the value of x there, so which means this would be for 4 marks. All right, now let's move on to the second one. Show that f of x is equals to 2 over x plus 1 plus 1. So now if you have f of x is equals to x plus 3 over x plus 1, the goal here is, since you want to write this as a partial fractions, what you aim at doing is you should try to manipulate your numerator, all right, your numerator such that it looks the same as the denominator. So if we want, there's x, we are sorted, but we have plus 1 in the denominator, we need plus 1 in the numerator. The only way to do that is if we break down 3 into what? Into, we can write it as x plus 1 plus 2, okay? Divide by x plus 1. So you see, I changed 3 to what? 1 plus 2, so that I can have something that looks like the denominator there, so that I can make it a common denominator. There are other methods that you can use to do that, but this is the easiest one. You try to manipulate the numerator such that it looks exactly the same or has the same terms as the denominator, okay? So now you can see x plus 1 plus 2, where if you add 1 plus 2, you will still get 3, okay? And then from there, we can divide each term by x plus 1. When we divide each term by x plus 1, this is what we get. We divide the first one by x plus 1, divide the second one by x plus 1. So the x plus 1 will divide out here. When dividing, you look for something common, and obviously cancel where possible, unless of course you are absent in the lower grades. All right, so now this one and this one will divide out. It will give you 1, so this is the 1 that you get. So this would be 1 plus what? 2 over x plus 1. Now when you write it, you change the order because addition is commutative, which means it doesn't matter which term you start with, as long as you are adding, that would always be true. So we change that to 2 divided by x plus 1 plus 1. So for 2 marks, we can actually mark the manipulation here and mark the simplification there for 2 marks. Remember, we're not going to award a mark for the answer because you were given what should be the final value. All right. Now we move on. Write down the equations of the vertical and horizontal asymptote. Remember, for you to do that, you need an equation in the form x plus p plus q. If you have it in that form, then x plus p equals to 0, x is equals to negative p. This gives you the vertical asymptote, and then you would have that y is equals to q, and this gives you the horizontal asymptote. All right, so you need the equation to be written in what? In this standard form. Okay, so now we've done that in the previous slide. We did write, if you check here, we did write the equation in the standard form. This is the equation in the standard form. All right, so we put it back in here, and then we're going to have that x plus 1 equals 0, which means that x would be negative 1 and y should be equals to 1. Okay, so that's what we get. X is negative 1 and y is equals to 1. Those are the asymptotes. 1 mark here, 1 mark there, a total of 2 marks. All right, now going to the last one, to sketch. Remember, when we sketch, we check. Now we look at the shape. Okay, the shape. The value of a is 2, which means a is greater than 0. We are expecting the graph to be on the first and what? The third quadrant. All right, but if we have asymptote, it should then shift with the asymptote, which means it would be on the first and third quadrant of the new set of the asymptotes there. All right, and we've worked out the x-intercept as well as the y-intercept. So this is how our graph would look like. Okay, you can see the graph is on the first and the third quadrant. There is the x, the y-intercept, there is the x-intercept, and these are our asymptotes. So we're going to mark the two asymptotes. Okay, and then we're going to give a mark to both intercepts. Okay, both the x and y intercept sketched correctly, and then we're going to give a mark for the shape. So that would be 4 marks. Remember, I said to you tomorrow, you use a pen to draw the graph, okay? Not a pencil, all right? Let's check now. I think we are done with the question. I think we did everything that was required of us in this particular question, okay? If you have any questions on this, please do post your questions on our WhatsApp interactive number. I think it is at the bottom of your screen now. You can actually ask us questions here. So as you follow the lesson and there are things that you do not understand, just send them through, talk to us so that we can look at that. But remember, the questions should be based on the lesson that is ongoing, okay? Right, now we'll move on to the next question. All right, remember I said all the questions would be done by you. My role would be to do the corrective work with you so that I show you where you've made mistakes in case you've made them. Now, this is the second question. All right, the parabola f of x is px squared plus qx plus r intersects the x-axis at a and c and the y-axis at b. The equation of the axis of symmetry of the parabola is x is equals to 3. M is the turning point of f. The line through a and b is given by that with n on BA. Okay, so now this question, you must try to do it, and I'm going to give you just 12 minutes. Okay. Right, hello and welcome back. I hope that you were able to fight it out. It's a very nice question. It's a bit different from the norm in the sense that you are not given the equation of a parabola, but they want you to get the x-intercept. Because if you check, A is an x-intercept and C is an x-intercept. This would have been nicer if you were given the equation of the parabola, but it's given differently now. You are given the axis of symmetry, x is equals to 3, all right? If they like, they may have given you the axis of symmetry like this. They say x minus 3 is equals to 0 is the axis of symmetry. So you still transpose the 3 and say x is equals to 3. Now, given that axis of symmetry, we now want to actually work out the coordinates of A and C. But you can see that A, fortunately, is a common x-intercept, right? So it's the x-intercept of the parabola and the x-intercept of the straight line. So to deal with that, we will work out the x-intercept of the straight line, since we are given the equation of the straight line like that. So let's quickly deal with that. Y is equals to negative x plus 7. So if we are looking for the x-intercept, we put y to be equals to 0. So when y is equals to 0, then we have 0 is negative x plus 7. Transposing the x there, we get x at A is equals to 7. So we have that x at A is equals to 7. So the coordinates here would be 7 and 0, because x at A is equals to 7. All right. Now, if we have that here, we have 7, and we have the axis of symmetry as 3, and we need this point here, that is x at C. All right, we know for a fact that the axis of symmetry is in the middle of the x-intercept. So it is referred to what as the midpoint of the x-intercept, right? That is the axis of symmetry. So if we know that the axis of symmetry is in the middle, then one can actually use the fact that x at C plus x at A divided by 2 is equals to 3. One can use the midpoint formula, all right, that we well know from what you call coordinate or analytical geometry, all right? So we can use that to say x at M, which is the midpoint, is equals to x at C plus x at A divided by 2, because the axis of symmetry is in the middle of what? The x-intercepts, right? So substituting thereof, the values thereof, there we get that 3 is x at C plus 7 divided by 2. So if we cross multiply there, we get 6 is equals to x at C plus 7. So x at C is equals to what? Negative 1, all right? So this would be negative 1 and 0, all right? Negative 1 and 0, like that. So how do we mark that for 4 marks? We are going to mark the substitution here. We will mark the answer there. We'll mark equating to 0 here. Mark the answer, so you get your 4 marks there. Right, moving right along. All right, that was the first one, the coordinates of A and C. So now we've learned that this is negative 1 and this is 7. And they say show that P is equals to negative 1, Q is equals to 6, and R is equals to 7. They want the equation of a parabola, and we know that if we are given these two x-intercepts, the equation would be x minus x1, x minus x2, all right? And then we'll need an additional point on the graph, all right? We'll need another additional point on the graph, which we can use actually the y-intercept of the graph, okay? Right, let's check. Now we can substitute x1 represent the x1 and x2 are the x-intercept. We substituted 7 on x1 and we substituted negative 1 because it now it becomes what? X minus 7, all right, into x minus -1. That's what gave us +1 there, all right? So now we can substitute, we can actually calculate the y-intercept because we are given the equation of the straight line. So what would be the y-intercept? We put x to be equals to 0, which means that a g of 0 would be equals to 7. So y would be equals to 7. So this point here is a point 0 and 7. So we can substitute the point 0 and 7. Where we see x, we put 0. Where we see y, we put 7. In doing that, we work out that this would be 0 minus 7, which is -7 times 1, -7a. So a is equals to -1. Now that we have a as -1, we can come back and substitute it here so that we work out the equation. Okay, so that's what we did. We substitute -1 for a, and then we use the distributive property now of the binomials, multiplying two binomials. Using the distributive law, we get that this is x squared plus x minus 7x minus 7. Simplifying that, we get -x squared minus 6x minus 7. So it means that f of x is -x squared plus 6x minus 7. So remember, f of x was given in the form px squared plus qx plus r. So we can be able now to work out the value of p, q, and r. P is -1, q is 6, and r is 7. All right. So that is how you are going to actually work out the equation of this particular parabola. Now, the reason why the examiner has given you these values, all right, it is because the examiner does not want you to get the questions after this one incorrect where the equation is needed, okay? So in your exam, when they say show that this is true, okay, even if you failed to show it, in the next questions after that, you can use it, okay? So that you are not disadvantaged in the next questions there, all right? Now, let's move on to Roman 3, the area of triangle AOB. Let's check now. This is AOB. You can see that this is a right-angled triangle, okay? And we have the coordinates of B. We have that is 0 and 7. We have that of A, 7 and 0. We have that of O as 0 and 0. So we can work out the length of OA, which would be 7 units. Can work out the length of OB, which would be 7 units as well. So we are having a triangle, all right, with 7 units here, 7 units there. We can use the area of the triangle as half base multiplied by the perpendicular height, okay? So OA is 7 units and OB is 7 units. So the area is half the base, which is OA, multiplied by OB, which is the perpendicular height. So this takes us to half of 7 times 7. So that takes us to 49 over 2 square units. That is how you work out the area. Substitution there, answer there, and then you get your 2 marks there. All right. I hope that you are still okay. Remember, if you are not, you can always ask us on our WhatsApp interactive number. All right. We move on. Now we're getting into the high order questions, your level 3 type questions here. All right. Use the graph to solve for x where f of x is less than g of x. Still, I would need the coordinates here, which is 0 and 7, and then the coordinates here, which is 7 and 0. Okay, they say for which values of x would f of x be less than g of x? So a graph of f here, to interpret this, they want the region where graph of f is below graph of g, all right? We need the region where the graph of f is below the graph of g. Now, for you to do that, you need to start on the points of intersection where the two graphs are equal, all right? So I'll normally draw vertical lines on the points of intersection here, all right? So I would have that this is 0 here, and this is 7 there, all right? So I need to check whether I am meeting the conditions between those 2 points of intersection. If you check on this side, from left to right, okay, you can see that this is the graph of G, this is the graph of F. This is the graph of G, this is the graph of F. This is the graph of G, this is the graph of F. So you want, if you check on the left-hand side, we are looking for where the graph of F is below. So if you check here, on the left-hand side here, the graph of F is below. So this side, the graph of F is below. Let's check in between the vertical lines. Between 0 and 7, the graph of F is above. So we don't want the solution there, all right? And then let's check also on the right-hand side. On the right-hand side, from 7 going that way, we can see that the graph of F is below. So the answer is there as well. So the answer would be values of x that are less than 0 and values of x that are greater than 7. Okay, so we would have that x should be less than 0 or x should be greater than 7. It's a mark for each, and that gives us a total of 2 marks. All right, and then we move on to the last one. Very interesting. It infuses the nature of roots. For which values of k will f of x equals k have 2 positive roots? All right, so this we want it where it has 2 positive roots. So for us to be able to determine the region where it has 2 positive roots, we are going to start where now? We are going to start at the turning point, okay? We are going to start at the turning point. So if you are to draw a line below the turning point, what do you notice? It cuts twice, all right? It cuts twice on the positive x-axis. As you go below, it cuts twice on the positive x-axis. Now look at point B. Now it is cutting once on the positive x and it is cutting at 0. So that is where it starts to change, because below the y-intercept you can see it's cutting on the negative x-axis and also cutting on the positive x-axis, because we are working with f of x equals k, which is the line y is equals to k. This is our horizontal line. So we are using the horizontal line to test this, all right? So you can see that when the horizontal line is between the turning point, all right, just below the turning point and just above the y-intercept, you see that now the line intersects the parabola twice on the positive x-axis. So, but the problem with this question is that we do not have the coordinates of the turning point. We only know that x is equals to 3 here. We don't know what y is equals to. So we'll start by substituting the axis of symmetry onto the original parabolic equation to get the value of y, and hence to determine the coordinates of the turning point. All right, so we substitute 3 on the equation of f, so we get that f of 3 is equal to 16. So we can conclude that the turning point is what now? It is m 16. So I just want to show you the rough sketch there, where this is the graph and this is the parabola there. So if you check between the turning point, just below the turning point, it is cutting twice. That is the line y is equals to k. Just below the turning point, it's cutting twice on the positive x-axis. But when you get to the y-intercept, you see that it now cuts on 0 and it also cuts on the positive x. So 0 will not be included because 0 is neither positive nor negative. So we have to be moving between the y-intercept and the turning point, which means y should be trapped between what? The turning point, all right? Between the turning point and the y-intercept and what? And the turning point, the y value of the turning point. So our y, which is k in this case, k should be trapped between what? 7, which is the y-intercept, and 16, which is the turning point. So that is where the line of interest should be moving in between, all right? So you are not using the discriminant. There is no way in which you'll get a correct answer by using the discriminant. So here we are using the graphical approach, okay? We are infusing the knowledge of nature of roots to the graphical approach. It is a higher order question. I hope that it made sense to you. All right, I'll quickly explain it again. We wanted where the horizontal line will cut on what? On the positive x-axis. Will cut twice on the positive x-axis. So that happens below the turning point and above the y-intercept. But we did not have the turning point. So we started by determining the coordinates of the turning point using the axis of symmetry. Then we define that line. So substitution here, it's a mark. And then the value of the y value of the turning point is a mark. And then you have 2 marks here, which gives a total of 4 marks, all right? I hope that you are still okay, all right? Now I wanted to move on to the next question, okay? That this is the last question on functions that I want you to do. It's a question on inverses, all right? It's a question on inverses. Now, this is the question. The question is out of a total of 8 marks, so I am going to give you 6 minutes, all right? 6 minutes to work on that. It's not a difficult question that much, but there's a trick with this question because you have to check this particular graph here. It has what? It has an endpoint. So that endpoint affects what? The domain. It affects also the range, all right? It can also affect the way in which you can draw or sketch the inverse of this graph. So look out for that particular endpoint, all right? So I'm giving you 6 minutes and your 6 minutes time starts now. Right, hello and welcome back. Let's go through the question. The diagram below shows the curves f of x is a quarter x squared, where x is greater or equals to 2 or negative 2. So you are told that this graph exists from here until there, okay? That is the domain there, all right? And g of x is a to the x, where a is superior than 0. The point a, negative 1 and 3, lies on the graph of g. Show that g of x is the third to the x, okay? So that's where we start, okay? Now, it means that we will have to substitute this point. Where we see x, we put negative 1. Where we see y, we put 3 on that particular equation of g of x, okay? So it's 3 is a to the negative 1. So a is equals to what? A third. Because remember, when you have 3 is equals to a to the negative 1, this is the inverse law. We can then say 3 is equals to what? 1 over a. And then if we cross multiply, 3a is equals to 1. A is a third, all right? Or if we like, you can actually, 3 is a to the negative 1, can multiply both the numerators by negative 1. So this would be a is to the power 1. So a is equals to 1 over 3. So that's just the algebraic manipulation, all right? So we're done with that substitution answer. 2 marks, all right? Moving on, determine the inverse of f in the form y is equals to. So this is the graph of f. We want its inverse, okay? We want the inverse y is equals to a quarter x squared. So inverse, we interchange x and y first, all right? So that is what we do here. We swap x and y, okay? We interchange x and y, all right? And then from there, we make a y the subject of the formula. So we multiply both sides by 4, all right? So that we get y is equals to this plus minus the square root of 4x, which means y is plus minus the square root of 2. It's plus minus 2 root x, and x is greater or equals to 0. Remember here, the condition was, if you check here, the condition was that the graph has what? The condition was x is greater or equals to negative 2 and y is greater or equals to what? 0, because the graph exists above the x-axis. So when you interchange x and y, then this would be y is greater or equals to negative 2, and for the inverse, all right, x is greater than or equals to 0, all right? So that is where that domain, the range for the function now becomes the domain for the inverse. So it's 2 marks, interchanging x and y, and we can mark this one where y is made the subject, 2 marks, but you need to put the plus minus there, all right? Plus minus is imperative there, all right? So let us continue with this. The third one, sketch the graph of the inverse of f. If we do that, then that is what we are going to get, okay? So that is the graph of the inverse. You can see now this value of x here interchanged and became the value of y. So that will be the inverse there, all right? So it's 2 marks. We are going to mark the end point, okay? The end point, and then we are going to mark what? The shape. So this gives us a total of 2 marks. Now determine the inverse of g in the form y is equals to. So the inverse of g, we had g of x, we interchange x and y. You see here, that is where we interchanged x and y, okay? We interchanged x and y, all right? So we make y the subject by making use of logarithms, okay? So this is using the log of a number, all right? The log of a number to its base is equals to the exponent. Remember, this is born from the base to the exponent is equal to what? The number. So that is how we move from a log form to exponential form and vice versa. Okay, that is how we move from log form to exponential form and vice versa. So we're going to allocate a mark for interchanging x and y, all right? And then we are going to allocate a mark for the answer using the logarithm. So this will be 2 marks, all right? So this concludes the questions on functions, all right? Which means we have to now go to differential calculus and respond to the questions there. But first, we are going to look at the checklist, okay? That would allow us to be competent in terms of a differential calculus, right? So that is the checklist for differential calculus. Solve problems involving limits. Remember, sometimes you can be given the limit as x tends to 2 of x squared minus 4 divided by x plus 2. All right. So to solve this, we can always go for the limit as x tends to 2 of what we factorize x minus 2, x plus 2 divided by x plus 2. So the x plus 2 and the x plus 2 will divide out. So we are left with now the limit as x tends to 2 of what now? Of x minus 2. So if x tends to 2, then it means that you'll have 2 minus 2. This limit converges to 0. All right. So it's important for you to know how to solve questions involving limits. If you do that, then you can give it a tick. And then the derivative by means of first principles. Remember, in your June exam, you were presented with f of x is equals to what? Something like 2 to the 2 over x, a reciprocal function. You should be able to work with that as well. Remember the standard functions that are tested, ax squared plus bx plus c, all right, f of x. You also have f of x is equals to a, the constant, f of x is equals to mx plus c or ax plus q, all right? You also have f of x is equals to ax cubed. So those are the standard functions that you can be tested on for first principles, as well as f of x is equals to a over x. So those are the ones you need to know. So please do practice the cubic one and also do practice the reciprocal function one, because those are normally the ones that give you problems, all right? Use the rules of differentiation to find the derivative, all right? And then solve problems involving average gradient and gradient at a point, all right? Use the factor theorem to factorize cubic functions, sketch cubic functions, determine the equation of a cubic function, all right? So those are things you should know. Also, solve questions involving the derivative of a cubic function, interpret sketched cubic function, solve problems involving practical application of calculus using the theory of shapes and measurements, all right? So that is optimization now. Solve practical problems of application of calculus, okay? Solve problems involving the practical application of calculus to graphs, sorry about that. So where you determine the maximum distance between two functions and so on. All right, solve problems involving practical application of calculus to rate of change and the calculus of motion. So those are things that you actually need to master and know. All right, so that would sum up the checklist as far as calculus is concerned. All right, now I want us to look at the questions. This is normally the first question on calculus. It's on first principles and the rules of differentiation. All right, I am going to give you just 10 minutes to work around this. All right, just 10 minutes to work around these 3 questions. Okay, so your 10 minutes time start now. Please work as quickly as you can. Right, hello and welcome back. I hope you were able to answer these questions just to warm up on the calculus. All right, that's normally how your question papers are structured in terms of a differential calculus. All right, now I want us to go through the solution set. We start with the first principles. Remember, here we have to compute f of x plus h, right? That's where we start. Okay, we have the f of x there. We compute f of x plus h, meaning where we see x, we put x plus h. So you can see here the x was replaced by what? X plus h. And also the x was replaced by x plus h. And then from there we simplify. Normally I would say start on the, this is negative into what? I would normally say start on the brackets there. Okay, create a square bracket, and then from there simplify inside, where this would be x squared plus hx plus hx plus h squared, which would give you x squared, all right, plus 2hx plus h squared. And then you can distribute to get what I wrote there. Negative x squared minus 2hx minus h squared, all right? And then also distributing here, okay, plus 2x plus 2h, all right? So that is you computing f of x plus h, all right? That is the substitution there. That is the simplification of the computing there. And then the first principles formula that is in the formula sheet, okay? And then you get a mark here for substitution, all right? Substitution into the first principles, all right? And then you get a mark also for simplification. So after substitution, what we do is we distribute here, all right? When we distribute, we get positive x squared minus 2x. The rest of the stuff, I kept it as it is. So this one and that would give you 0, all right? And then this one and that will give you 0 as well, all right? So it gets you to negative 2hx minus h squared plus 2h divided by h. So we can take out a common factor of h. So by factorizing here, taking out the common factor of h, okay, this is for the common factor, all right, and then this is for the substitution, all right, and then from there, once this and this divide out, and then we approximate h to 0, we get negative 2x plus 2. So this gives us a total of 5 marks, all right? So that is how you are supposed to go through this one. And I know that almost all of you were able to get this one correct, all right? Please make sure you keep on practicing it. It's marks that you can get tomorrow, all right? And now, the rules of differentiation. What I normally say is that the basic rule here is that there should be no brackets, all right? There should be no radical signs, all right? And then there should be no fractions, all right? Where the fractions here, the fraction is defined in this context as any value that has a numerator but whose denominator contains the variable that you want to differentiate for. All right, so 1 over 2 will not be what we are interested in, but 1 over 2x will be what we are interested in because there is the variable that we are differentiating with respect to, and it's in the denominator. Okay, so when that variable is in the denominator, we say that we would have a fractional differentiation there, and we don't need that. So we would need to arrange everything in the form axn plus bxn and so forth. All right, so let's look at the first one. All right, now when you look at the first one, does it meet the 3 conditions? No fractions, no brackets, no root signs, no fraction. Let's check. If you check here, there is a root sign. So the first condition is not met, or the condition for root signs is not met. So which means we have to convert to exponential form. And then this one has what? The expression or the variable we want to differentiate with respect to, it's on the denominator, so we have fractions. And then what about the brackets? We do not have any brackets, so we need to deal with the two things that are actually inhibiting us from differentiation. What are those two things? The root signs, as well as what? As well as the fraction. So to deal with the root sign, we are going to use the fact that if you have the nth root of a to the m, converting this gives us m over n. So if we deal with that, we get that it's 4 over 3, all right? And then we move that part here to the numerator using the inverse law. The inverse law of exponents states that if you have 1 over a to the m, this becomes a to the negative m. So when you move that, the exponent becomes negative. So we can differentiate. When differentiating, obviously we are using the fact that d dx of ax to the n is equals to what? A n x n minus 1. That is the rule that we are using, all right? So when we differentiate the first one, this is what we get. When we differentiate the second one, negative 2 times 2, which is 4, and then we subtract 1, x to the minus 3. And then this was a constant because it does not contain x. The derivative of a constant is 0, so that now we get 4 marks. 1 mark for simplifying, and then we get the 3 marks for each differentiation. That is 4 marks, all right? Moving on to the next one, all right? I think I rewrote that as it is there, so there was no need for this particular step. We were just going to remove the 0 there, okay? The second one, now if you look at the second one, y is not the subject of the equation. So first thing that we need to do is to make y the subject of the equation, all right? So what do? We are going to, there's a mistake here, it should still be 8, okay? So we are going to transpose 1 to the left-hand side and then transpose everything else to the right-hand side. We leave 8x cubed on the left and transpose 1 to the left, send everything else to the right-hand side, okay? So this becomes y is equals to, now we are going to take out a common factor of y here, which means that we would have y into 2x minus 1, okay? And then from there, we divide both sides by 2x minus 1, all right? So that we will now get everything written in terms of x. So y is 8x cubed minus 1 over 2x minus 1. And this is the difference of 2 cubes from grade 10, okay? Difference of 2 cubes, okay? From grade 10. How are we going to deal with the difference of 2 cubes? To deal with the difference of 2 cubes, if you are given a cubed minus a b cubed, this is equal to, you take the square root, the cube root of the first term, that is a, all right? So that would be a minus b, okay? Let me write it here, okay? Allow me to write it here. A cubed minus b cubed, this would be a minus b, and then you square the first term, a squared, you square the last term, b squared, and then the product of the two terms, ab, all right? And then from there, the sign, the first sign would be opposite of what was in the expression, so it would be positive. The last one is always positive. So we need to apply the same formula to find the difference of these cubes. So we have that this is 2x minus 1 because that is the cube root of 8x cubed. That is 2x. and then the cube root of 1, that is 1. All right. So if you take the first term and square it, it's 2x squared, which is 4x squared. You square the last term, you get 1. So what happens is that you take the first term, which is 2x minus 1, and then you square the first term, you get 4x squared. You square the last term, you get 1. And then you multiply the product of the two, you get 2x. And then the signs would both be positive. So this one and this one will divide out. So you'd have y is equals to 4x squared plus 2x plus 1. Then you can be able to differentiate dy dx gives you 8x plus 2. So we can mark that 2 marks here, and then a mark for making x the subject and a mark for factorizing. All right, so here x the subject, and then here factorizing. Here is the mark, these marks are for differentiation. All right, so that is how you'll work that out, and then this would be for a total of 4 marks. All right, so that is basically how you go about that one. It's a very, very nice question. Please re-look at it on your own and try to solve it on your own there. All right, moving on. The next question now speaks to the equation of a tangent to a curve. All right, so for this question, I'll give you a total of 6 marks. Okay, no, it's for 8 marks. So I'm giving you a total of 6 minutes. All right, a total of 6 minutes. I made a mistake there. So your 6-minute time starts now. Right, hello and welcome back. Now, let's look at these two interesting questions. Very, very nice. All right, let's check the first one. If f of x is negative x squared plus 3x and g of x is 2x squared minus 3x, determine the value of x for which the tangent of f is parallel to the tangent of g. All right, the tangent of f is parallel to the tangent of g. So what does that mean? If the tangents are parallel, it means that if we are having these two tangents being parallel, let's say that this is the tangent of f, all right? Tangent of f, and this is the tangent of g. If they are parallel, what do we know about the properties of the gradients of parallel lines? It means that the gradient of the tangent of f would be equal to the gradient of what? The tangent of g, all right? So that is how we work out the properties of gradients, all right? That's how we deal with that. So if we are to find the gradient of f and the gradient of g, all right? The gradient of the tangent of f and the gradient of the tangent of g, and we equate them because the tangent of f is parallel to the tangent of g. Now, in the context of calculus, we know that to get the gradient of the tangent, if we find the derivative f prime of x, this gives us what? The gradient function for f. So this gives us the gradient of the tangent of what? Of f. All right. If we are to determine the derivative of g with respect to x, this gives us the gradient function. All right. For what? For the tangent of g. All right. So that's what we are going to do. We differentiate f to get the gradient function of what? The tangent of f. And then we differentiate g to get what? To get to the gradient function of the tangent of g. And then using the fact that the tangents are parallel, we are going to then equate their gradient functions, all right? So that would allow us to get the value of x. Okay, let's go through that. First, we determine both gradient functions. So the f of x is negative x squared plus 3x. The gradient function is what? Negative 2x plus 3. G of x is 2x squared minus 3x. The gradient function is 4x minus 3. So we've worked out both the gradient functions, all right? But now we know we equate now the gradient function since the tangents are parallel, all right? So we are going to equate f prime of x to what? To g prime of x. All right, because the gradients are the tangents are parallel, which means that the gradients are equal. All right, so now when we equate them, we get negative 2x plus 3 is 4x minus 3. Solving for x, we transpose negative 4x to the other side becomes negative 4x minus 2x, which becomes negative 6x, is equal to negative 3. We transpose the other 3 to the right hand side to get negative 6, so that x becomes 1. All right, very, very nice and interesting question. Okay, so you've worked out the value of x. All right, so the equating the two, f primes of x is equal to g primes of x. You get a mark, and then you get a mark for the answer. You get a mark for f primes of x. You get a mark for g primes of x there. So this is a total of 4 marks, okay? Now, let's move to the last question on these tangents, all right? It says, determine the point on f which the gradient is equal to negative 9. So we are given the gradient of a tangent of f is equal to what? Negative 9. What do we know about the gradient of the tangent of f? It is the derivative with respect to x of the function f. All right? So we work out the gradient function of f. We've already done that before, which gave us negative 2x plus 3. And then this is what? This is the gradient function, all right? The gradient function, all right? Already we have the gradient, which is negative 9. So we equate the gradient function to negative 9. If we do that, we get that negative 9 is 2x plus 3, and then we are going to transpose the 3 to the left hand side. We get negative 9 minus 3, which is negative 12, is equal to negative 2x. We divide both sides by negative 2, we get x is equal to 6. That is the x value of the point of what? Of the point of tangency, all right? Or what we call the point of contact, all right? So now we are going to go back to the original equation to substitute the x value of the point of contact to f to get the corresponding y value, all right? So when we do that, we get that f of 6 is 6 squared plus 3 into 6, which gives us a negative 18. So the point of tangency here, or the point of contact, is 6 and negative 18. All right. Hope that you understood how we came about that. Remember, if you have questions, please do text us on our WhatsApp interactive number. We'll be able to respond to all your questions. All right. Now let's move on to the last question for our revision preparation. All right. So this question, I'll take you through it. Okay. We no longer have enough time, so I won't give you time to go through it, but I'll take you slowly through it. All right. Consider the function f of x is x cubed minus 4x squared minus 11x plus 30. Use the fact that f of 2 is equal to 0 to write down the factor of f of x. Number 2, calculate the coordinates of the y-intercept of f. Number 3, calculate the x-coordinate of the x-intercept of f. Calculate the coordinates of the stationary points of f, and then sketch the curve. All right, let's start. Use the fact that f of 2 is equal to 0, so to find the factor of x. So x is equal to what? 2. That is, f of 2 is equal to 0, because that's where x belongs, which means that x minus 2 is a factor. All right, that's the first one. X minus 2 is a factor of f. That is 1 mark. Coordinate of the y-intercept. Y-intercept, we know. Y-intercept, what do? X becomes 0. All right. So if x is equal to 0, what happens? Everything here is 0, 0, 0, and 30. So the y-intercept is 0 and 30. All right. So for that, you are going to get 1 mark as well. All right. So we move on to the coordinates of the x-intercept. Now, let's check x-intercept. For x-intercept, y equals 0, all right? When we equate y to 0, what are we going to get here? We should then be able to get to a space where we have a factor, all right? What is our factor? We said x minus 2 is equals to 0. So our x equals 2 is that factor there. So taking the coefficients 1 minus 4 minus 11 plus 30. So if we start, we're using synthetic division. So we always start with a 0 there. 1 plus 0, that is 1 times 2. That is positive 2. All right. And then negative 4 plus 2, that is negative 2. Negative 2 times 2, that is negative 4. Negative 11 minus 4, that is negative 15. Negative 15 times 2, that is negative 30. And then this becomes 0, which means that this is our x squared, this is our x. So we're using synthetic division. Remember, you can use long division method, or you can use the method of inspection, all right? So now, here you can see we made use of the synthetic division method. I've just taken you through that, okay? And then from there, what do we get out of that? X minus 2 into that. So this would be a mark as well as a mark for the method, okay? This mark here goes to what? To the method. And this mark here goes to the simplification of the method, and then here it goes to what? Factorizing, all right? factors, okay? And then from there, we get the values, all right? X values, okay? So we can obviously write down the coordinates there, 2 and 0, minus 3 and 0, 5 and 0. So we factorize x squared minus 2x minus 15. Okay, we got x plus 3, x minus 5. And then from there, x equals negative 3 or x equals 5. And then we can write down the coordinates of the x-intercept, all right? So that would be the next question, all right? Then we go to question D, where they want the stationary points. Stationary points are the same as what we call the turning points there, all right? The turning points. So what do we do to do that? We must solve f prime of x is equals to 0. That's how we get the turning point. So we get f prime of x, that is a mark for that, all right? And then we equate that to 0. Normally, you would also be credited with equating that one to 0, but at times it is implied. Let's say that it was not allocated a mark here. If it was not allocated a mark there, then we have the factors. It's a mark for the factors, all right? And then it's a mark for both values of x. Remember, you can also here make use of what? A quadratic formula. Nothing stops you from making use of what? The quadratic formula. You'll still get marks, all right? So you get x is 11 over 3 and x is negative 1. And then you substitute that back to get the corresponding values of y, okay? So this question was in fact supposed to be for 5 marks. 4 marks is too low on that question. It was supposed to be 5 marks, so we get 5 marks there. So you can see here that we differentiated, we equated the derivative to 0, okay? And then we solved for x to get the x values of the stationary point, and then we substituted them back into the original equation to get the y values, okay? That's how you were going to go about that. And then from there, we must sketch the function, all right? So these are the turning points, the coordinates of the turning points, okay? So now we need to sketch the function, all right? Let's look at how we could do that. Now, you need to show all intercept with the axis. Now, this is how you were supposed to sketch. This is the y-intercept, okay? This is the y-intercept. We've calculated it. And these are our x-intercept. So the star represents our x-intercept. All right, and then this is the turning point. We determined the coordinates in the previous slide, and this is another turning point. Remember, you have to know, and then the shape as well. A is 1, A is greater than 0, which means that we have a shape like that. All right, so that is our function there. So we get a mark for the x-intercept, all right? We get a mark for the turning point or the intercept, all intercepts, okay? We get the mark for the turning point and we get a mark for the shape, all right? So this gives us a total of 3 marks. So that's how you are supposed to sketch that cubic function. Remember, do extend your preparation to interpreting a cubic function as well as to optimization, all right, which is the application of calculus. All those concepts are examinable, all right? So I would advise you on this day that you should practice, and practice. You see, I've mentioned it 3 times because I want you to thoroughly practice, but remember to rest, okay? Remember to rest as well. So practice, and practice, but give yourself about 6 hours of sleep, okay? About 6 hours of sleep, you should get it, so that by tomorrow you are fresh and ready to write, okay? Let's preview our next lesson, okay? Our next lesson would be tomorrow, all right? It will be tomorrow on the 31st, and it is on paper 2 revision, and we'll be revising, focusing on analytical geometry and trigonometry, all right? That would be tomorrow from 14:30, all right? We start at 14:30. So when you come back from the exam, you rest, and then 14:30, we start preparing for paper 2. Right. I wish you all of the best. I hope our lessons for the year were able to assist you to become better mathematicians. All of the best for tomorrow. Please take care of yourselves, take care of each other, and practice mathematics. Goodbye.